Hi, this is Antonius Frentis. Welcome to part 3 of a 3-part video tutorial which describes the basic concepts of MiceOnABeam through the creation of a script for a secure door in Second Life. If you haven't seen parts 1 and 2, please view them now. In this part 3 of the tutorial, we'll modify the design to verify that the avatars trying to enter the door are authorized to do so. So here's the model from where we left off in part 2 of the video. At this point, we already completed the logic to open and close the door, as well as to read a note card containing the names of the avatars that will be permitted to use the door. Note how the visual model clearly separates out these functional parts of the script. The read note card state covers the initialization and handles the data server event for reading the note card. When there are no more lines to read in the note card, the script moves to the door handling part of the model, where the closed and open states handle the touch end and timer events. Our final set of changes will be made here in order to check that the avatar touching the door is a member of the list of authorized names, which was saved in the state variable whitelist. So moving forward, add another choice point to the model and name it Test if authorized. Select the touch end transition from closed to opened and click and drag its endpoint from the open state to the new choice point. Then create a new transition from Test if authorized to the open state. Open up its Properties editor and rename the new transition to Yes. Now it's here where we need to add the code to verify that the avatar who just touched the door is a member of the whitelist. Add the following code to the transition's guard condition. Here we make use of the LSL function listFindList, which searches the list entered as the first parameter for the value specified in the second parameter. If the value is found, then the function returns its index within the list, which is always greater than or equal to 0. And so the guard condition will return true in this case. For the second parameter, we call the LSL function detectedName, which returns the name of the avatar who touched the door, and enclose it in square brackets to create a list consisting of a single element. As a nice touch, let's have the door issue a message greeting the avatar who successfully opened it. We can use the built-in LSL action SaySomething for this. It can be found in Insert Action, Communication, SaySomething. Again, use the detectedName function to get the avatar's name. Select the Whisper option so only those nearby will get the message. Next, create a new transition from Test if authorized back to the closed state. Edit the properties of this transition and change its name to No. Set its guard condition to Else. and this transition will be taken if the avatar is not authorized to use the door. We're almost done here. Whenever the note card is updated, its information must be reread by the script and the door closed if opened. To do this, we're going to make use of the powerful Group Transition feature. So draw a transition from the top state's border to the read note card state. We'll make a little room here for that. Open up its properties and set its event to onRes. This will handle the case when the door prim is resed. Now add a call to the function init that we previously created to initialize our key variables on the onRes. A group transition is just a shorthand notation that acts as if the transition had been connected to every state within the composite state from whose border it's drawn. It can really help simplify what would otherwise be a more complex model. Now add a second transition from the top state's border to the read note card state. Edit its properties and set its event to changed. Set the guard condition to detect the case when the contents of the note card has been changed. The change argument tells the script the reason for the changed event, and we test it against the built-in constant changed inventory by doing an AND operation of the bit field. Bit fields are a slightly more advanced operation which you can read about in the LSL portal documentation for the changed event. Finally, as for the onRes transition, add a call to the init function in the transition action. So there you have it, a complete MiceOnABeam model for a secure door script. Go ahead and test out your new model. Don't forget to create a note card named whitelist and copy it to the inventory of the prim containing your door script. Once you've determined that everything is working perfectly, generate your final deployed script using the Generate LSL Optimized menu item from the script menu. This will produce code with a smaller footprint, eliminating all comments, and as well will perform some coding optimizations. Here's a recap of things to remember from all three parts of this video series. Create a separate state when you need to handle one or more events in a unique or different way from other parts of your script. Don't forget to specify the default state for the script or for any composite state. To handle a particular event that occurs within Second Life, you must create a transition in your model and assign it that event. To enable or disable the handling of an event, assign an expression to the guard condition that evaluates to true or false. To carry out an action when an event occurs, enter it in the transition's properties. Alternatively, action code can be executed any time a state is entered or when it is exited. A state function can be used to package up a group of LSL statements that can be called from anywhere within that state, saving you from having to duplicate code in multiple places. Variables and functions defined for a state can only be accessed from within that state and all of its substates. A choice point is only used when a decision has to be made as to which state to move to after receiving an event. It should not be used for every if-then-else statement that would normally be part of your code. The conditional test for a choice point is specified by the guard conditions of each of its outgoing transitions. The transitions are tested in turn, and the first one whose guard condition evaluates to true is taken. If none evaluate to true, then a transition whose guard has been set to else will be taken. Many events have data arguments associated with them when they're received. These argument values can be directly accessed by name only within the guard condition and action code of the transition where the event is defined. To access them within a continuing transition, such as those leaving a choice point, you can either save their values in state variables or use the built-in event functions that MiceOnABeam provides. A group transition is a powerful modeling construct that acts as if the transition had been connected to every substate within the composite state from which it's drawn. To generate your final deployed script, always use the Generate LSL Optimized menu item from the script menu. So I hope you've had fun creating the secure door script and learning the basics of MiceOnABeam along the way. You've seen how by using just states, transitions, and choice points, you can create a really useful script. The complete MiceOnABeam model for the secure door can be downloaded at www.miceonabeam.com/video-models. Bye for now.